In class, we rigorously developed all the ideas in section 6.1. This short video, on the other hand, will be a brief summary of all the key ideas with some key examples for section 6.1. Remember that these 8 esteemed authors wrote this book with an audience in mind, and the audience in mind was you. So don't forget, reading section 6.1 might be part of your strategy for deeply learning these ideas. Let's begin our quick summary of the ideas from class that we rigorously developed. In summary form, for any n-gon, we have red interior angles and blue exterior angles, and the sum of all the red interior angles will be the number of sides minus 2 times 180. The sum of all the blue exterior angles will always be 360. It doesn't matter if this polygon has 5 sides like this picture or 5 billion sides. The exterior angles will always add up to 360. Finally, for any pair of interior and exterior angles, they always form a linear pair, and therefore they will always be supplementary. And if they add up to 180, then anytime you know one, you can subtract it from 180 to find the other. Recall that these formulas are for any polygon. On the next slide, we will deal with polygons which are regular. Well, it's still true that the sum of the interior and exterior angle pairs will always be 180. So when you know one, you can subtract it from 180 to get the other. But since regular polygons are polygons where all the interior angles are congruent and all the exterior angles are congruent, then if we know the sum of all the interior angles or exterior angles, you can just divide by how many of them that there are to get the measure of a single one of them. So the measure of each interior angle in a regular n-gon will be the sum of all the interior angles, which uses our formula, divided by how many there are. And the measure of each exterior angle will be the sum of all the exterior angles, which we know is always 360, divided by how many of them there are. All right, in the next slide, we're going to summarize the last 2 slides in one formula box. There's all those ideas, and we probably spent 70 minutes developing all of them rigorously in class. But here they are in a summary formula box. If we're talking about any n-gon, then these are the formulas we need to know. And if it's a regular n-gon, then these are the formulas we need to know. Finally, if we are asking for the measure of the interior angle of a regular n-gon, it's going to be a lot faster to do something besides this formula. We can use the formula, that works fine, but we can also say if you want the interior angle and it's regular, we can just divide the number of sides into 360 to get the exterior angle, and then subtract that from 180 to get the interior angle. All right, this is a summary of everything from section 6.1. However, there are some vocabulary words from our notes from class, and if you're absent, you should read the textbook. Things like convex polygons versus concave polygons. The word diagonal, the word vertex, or the plural of vertex, vertices. If you miss class, you should definitely read section 6.1 and make sure you're familiar with these formulas. For the next few slides, we'll do some examples that use these formulas. All right, for good examples, you can check 6.1 in the textbook. I'm going to do 15 examples here, and these are straight from the guided practice section of our textbook. Number 1, explain why an equilateral polygon is not necessarily regular. Because to be regular, you have to be equilateral and equiangular. And here's an example of an equilateral polygon. All 10 sides, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, are congruent. So it's equilateral. but it's not equiangular because we have these smaller angles which are all congruent at the tips of the star, and then we have these inside angles which are bigger than 180 degrees. They're all congruent, but the yellow angles and the white angles, they're not congruent. It's not equiangular. So this is an equilateral polygon, but it's not regular. Regular would require both equilateral and equiangular, and it's not always the case. Are these shapes polygons? Yes, and it has 10 sides, so it's a decagon. This shape is not a polygon because its sides aren't segments. This shape has 4 sides, so it's a quadrilateral. And this shape is not a triangle. Since this side is not a segment, it is not a polygon. Regular or irregular? Well, it's equilateral and equiangular, so it's regular. This side is not equilateral nor equiangular, so it's irregular. This side is equilateral for congruent sides, but it's not equiangular, so this is an irregular polygon. Now, what about concave or convex? This one is convex, this one is convex, and this one, you can see it's like caved in. This one is concave. All right, how about number 9? Let's find the measure of each interior angle of pentagon ABCDE. All right, here's pentagon ABCDE. So how do we find the measure of each of these angles? You'll need to know what Z is. Notice these are interior angles. Therefore, we know that the sum of these interior angles, we can add them all up, there it is equal to the formula for the sum of the interior angles of any polygon, which is 180 times the number of sides minus 2. This is a pentagon. You can count them 5 sides, so n is 5. So all the interior angles added up together is 20z, and we know that it has to be 180 times the number of sides minus 2, which is 540. Therefore, z is 27, and then we can substitute 27 in for z to find the measure of each of these angles. And that's how you do number 9. How about number 10? Let's find the measure of each interior angle of a regular dodecagon. These are our formulas. We're looking for an interior angle, and it's regular. So for the regular formulas, we have 2 ways to find the measure of the interior angle. We can use this formula, or we can do it this green way, which I submit is going to be easier. In either case, we do need to know n, the number of sides. So this is a dodecagon, and that tells us that the number of sides is 12. So if we do it the green way, well, first we'll find the measure of the exterior angle, which is 360 divided by the number of sides. So 360 over 12 is 30. And now that we know the measure of the exterior angle, we can remember that the exterior and the interior are always supplementary. So 180 take away the exterior will equal the interior. Interior plus exterior is 180, so the interior's measure is 150. Now if you just use the formula, it's not that much more work. Let's see what that looks like. The measure of the interior angle for the regular polygon is 180 times the number of sides minus 2, all over the number of sides. So 12 minus 2 is 10, 10 times 180 is 1800, and 1800 divided by 12 is 150. It's the same answer. So go ahead and maybe spend 1 minute watching the video again for this problem and decide which way you think is easier. They both work fine. Number 11, let's find the sum of the interior angle measures of a convex 20gon. So, sum of interiors, that's going to be this formula right here, the sum of the interiors. It's the only formula that says sum of the interiors. And it is equal to 180 times the number of sides minus 2. It's a 20gon, so n is 20. So 180 times the number of sides minus 2. And that gives us 3,240 degrees. As it turns out, whether this polygon is concave or convex makes no difference. So this word was extraneous. It didn't affect our problem. Let us next take a look at number 12. Let's find the value of y in polygon JKLM, which is given to us in this picture. So notice right away that what's given are exterior angles. We know they're exterior angles because they form linear pairs with the interiors. Interior, exterior, linear pair. Interior, exterior, linear pair. Interior, exterior, linear pair. So what do we know about exterior angles? We know that the sum of the exterior angles for any n-gon is 360, and that's how we'll solve this problem. Add up these angles and set them equal to 360. Add them all up, divide both sides by 16. Y is equal to 22.5. What about number 13, the measure of each exterior angle of a regular pentagon? Well, it's regular. So for our regular formulas, there it is. The measure of an exterior angle is just 360 divided by n. So what's n? Well, it's a pentagon. So n equals 5. So using the formula, 360 divided by the number of sides gives us an exterior angle measure of 72 degrees. For the last two examples, we'll use this photograph of a traffic sign, and let's begin with number 14. Let's name the polygon by the number of sides. Well, there's 1, 2, 3, 4, 5. So there are 5 sides. That would make it a pentagon. And that's all this question asked for, but we could also describe whether it's concave or convex. And this is a convex pentagon. We could also say if it's regular or irregular. This is irregular. Not all the angles are the same. Not all the sides are the same. But all this question asked for, number 14, was name it according to the number of sides. And it has 5 sides, so it's a pentagon. All right, number 15, we've got some right angles, angle P, R, and T. And then we also have that angle Q and S are congruent. So let's mark those with some congruent arcs. All right, what are the measures of angle Q and angle S? So the first thing I'd ask you is, are these angles in question interior or exterior? And you would say they're interior angles. And I would say, okay, is this pentagon regular? And you would say, no. So therefore, we're going to use the formulas for any polygon. And we're going to use the one that deals with interior angles. The sum of all the interior angles is n minus 2 times 180. So we can say that the sum of all these interior angles, which is P degrees plus Q degrees plus R's measure, which is 90 degrees, plus S's measure, plus T's measure, which is 90 degrees, and that's all equal to, remember the formula, n minus 2 times 180. So number of sides minus 2 times 180. How many sides are there? It's a pentagon. So there's 1, 2, 3, 4, 5 sides. All right, so 90, 90, and 90 is 270. Remember that these are equal to each other. So let's say that their measures of these are equal to x degrees. So we can say that this is x degrees and this is x degrees because they're the same. Those angles are congruent. So we'll say 2x degrees. And that's equal to 5 minus 2, which is 3 times 180. Well, that's equal to 540. Let's write that in. All right, we'll subtract 270 from the left, and we'll subtract 270 from the right. We'll divide both sides by 2, and x is equal to 135. Let's go back and ask what they wanted. What are the measures of angle Q and S? We said that Q and S were each x, so we're done. The measure of Q and X, the measure of angle Q and the measure of angle S is 135 degrees. When we look at the picture, it sure seems like 135 seems about right. We can safely conclude this problem. And there you go, 15 key examples from section 6.1 I hope this helped. Please send me an email if you have any questions about the homework questions, and we'll make video explainers.